Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today I and my groupmate will talk about chromatography in the flower. Here's our slide.
Now we go through the introduction. What is chromatography? Chromatography is the general term used to describe methods where two or more compounds in a mixture are physically separated by distributing between two phases. These phases include a stationary phase, which can be solid or liquid supported on solid, and a mobile phase, which can be either a gas or a liquid flowing continuously around the stationary phase. This technique involves separating components based on their distribution between the mobile phase and the stationary phase.
Hello, my name is Siti Liana Aisyah from RAS 107A, and today I want to talk about theory of chromatography. Chromatography comes from Greek, which is chroma, giving the meaning of color, and graphy, which means to write. Chromatography was first devised at the University of Kazan by the Italian-born Russian scientist named Mikhail Sivet. He was born on 14 May 1872 in Este, Italy. He invented chromatography in 1900 during his research on plant pigments. He used liquid adsorption column chromatography with calcium carbonate as adsorbent and petrol ether or ethanol mixtures as eluent to separate chlorophyll and carotenoids. How chromatography works? Chromatography is a process in separating components or the colors of a mixture. The mixture is dissolved in a substance called the mobile phase, which carries it through a second substance called the stationary phase. The capillary action will carry the mixture up the paper or cloth, but the components of the pigment will not all travel at the same rate. Paper chromatography is a partition chromatography that contains 22% of water molecules absorbed on about 78 of cellulose. There are 5 types of chromatography. The first one is sanding paper chromatography. The technique goes with its name as the solvent moves in an upward direction. Second one is descending paper chromatography. The movement of the flow of solvent due to gravitational pull and capillary action is downwards, hence the name descending paper chromatography. Third one is radial or circular paper chromatography. The sample is deposited at the center of the circular filter paper. Once the spot is dry, the filter paper is tied horizontally on a petri dish which contains the solvent. The fourth one is two-dimensional paper chromatography. Substances which have the same RF values can be resolved with the help of two-dimensional paper chromatography. And the last one is circular paper chromatography. Movement of solvent occurs in two directions after a particular point. The solvent travels upwards on the paper which is folded over a rod, and after crossing the rod, it continues with its travel in the downward directions.
This slide shows the material used in our experiments. Hibiscus flower petals were used as the source of pigments. Solvent were used to the extracts and separates the pigments. Chromatography paper was used for pigment separations. A beaker was used to hold the solvents, while tape and a pencil were used to prepare and label the paper. Scissors were used to cut the petals and the chromatography papers. This slide explains the procedures carried out in our chromatography experiments using red hibiscus flower petals. First, 10 fresh red hibiscus petals were selected and cut into small pieces using scissors. The petals were then placed into a vessels and mortar and crushed thoroughly to break down the plant tissues and release the pigments. Next, a suitable spallium of acetone was added to the crushed petals in the vessels and mortar. The mixture was continuously ground until it forms a liquid paste. This step was important to ensure that the pigments from the flower petals were efficiently extracted into the solvents. After preparing the extracts, the chromatography paper was cut to 7.5 cm in width and 2 cm in length. A pencil was used to draw a straight reference lines about 2 cm from the bottom edge of the paper. Pencil was used instead of pen to avoid interference during chromatography. Then a small mark was made at the center of the pencil lines and labeled as red to represent the hibiscus flower extracts used in these experiments. This mark point served as the original where the sample would later be applied for separations of pigments during chromatography. This slide explains the next step of our experiments. First, a small drop of the hibiscus flowers extracts was placed on the marked spot on the chromatography papers using a capillary tubes. This step was done slowly and carefully so that the spot did not spread too much after placing the drops. The paper was left to dry. This process was repeated a few times until the colors on the papers became more concentrated and clearly visible. Next, the chromatography paper was hung inside a beaker by clipping it to a pencil. The pencil was placed across the top of the beaker so that the paper could hang straight without touching the side of the beakers. Inside the beaker, about 20 milliliters of solvents, which was a mixture of petroleum ethers and chloroform, was added. After that, the paper was left in the beakers and the solvent was allowed to move up to the paper slowly by capillary actions. The solvent was allowed to rise until it reached about the middle of the papers. Once this happens, the paper was carefully removed from the beakers. Finally, the chromatography papers were left to dry completely. The distance traveled by the solvents and the distance traveled by each color's pigments were measured. The measurements were later used to analyze and compare the pigments present in the hibiscus flower extracts.
So we move to the next slide, which is the slide show the setup of paper chromatography that we use to separate the pigment on the plant extract. First, we use pencil to draw the line near the bottom of paper chromatography. Why we use pencil? Because if we use pen, the ink will dissolve in the solvent. So the sample, which is plant extract, is placed on the line. So the paper is then placed on the jar which is containing the solvent. The bottom of the paper touch the solvent, but the sample spot must be above the line, so it does not directly into the liquid. As time passes, the solvent moves upward by capillary action. When the solvent reaches on the top, that point is called solvent front. As the solvent moves, it carries the different pigment in the sample. Each pigment moves at different speed depending on how soluble it is in the solvent. Okay, we move to the next slide, which is the slide show the result of chromatography after the solvent has finished moving up in this paper. So the starting line is where the sample was first placed. The solvent front shows how far the solvent traveled. So we can see a different color band on the paper. Each band represents a different pigment in the plant extract. The carotenoids appear higher on the paper because they are more soluble in the solvent. So they travel further. Meanwhile, the anthocyanins appear lower because they are less soluble and move more slowly. This shows the paper chromatography can separate plant pigment based on their solubility and the interaction with the paper and the solvent.
And finally, it's a conclusion. To conclude, this presentation allows us to explore various aspects of basic chromatography. It can be used to analyze the chemical composition of different flower varieties. Moreover, this technique has been widely used in variety science fields. The application is diverse and have potential to revolutionize various fields. That is the end of our presentation. Thank you.